Hello there, Mr. Sutton here, bringing you this lesson on systems word problems. In this one, we're going to do some real-life applications of systems of equations. In particular, we're going to solve word problems involving coins and other objects. For the warm-up on this one, we're being given this problem with Mullah, who has 24 coins that are dimes and quarters, and we're told the value of all the coins is $3.75. Our task is to first set up a system with two equations that models the situation, and then solve it to see how many dimes and quarters Mullah has. Alright, so first thing you need to do on these problems is define variables for the things you're trying to solve for. We want to solve for the number of dimes and the number of quarters, so we need a variable to represent each of these. I'm going to let D represent the number of dimes, and you should spell this out so that people know what you're talking about, and then Q is the number of quarters. Once you've defined those, go ahead and use your variables in two different equations. So I'm going to let you pause the video and see if you can actually come up with two equations using D and Q to represent this situation. Alright, so in this problem, we've got two different takes on the information. The first piece of info they gave us is the number of coins. Now we know that if I take the number of dimes and add that to the number of quarters, I should end up with 24 coins. So we can write an equation talking about the number of coins. We can say number of dimes, D, plus number of quarters, Q, equals 24, and that gives us one equation. But this by itself is not enough to know how many dimes and quarters we have because lots of things add up to 24. So this is where we need a system of equations, another equation using information about the number of dimes and quarters. The only other info they gave us was talking about the value of all the coins. So we're going to write an equation using that quantity. So I know that if I take the value of all the dimes and add that to the value of all the quarters, that should add up to $3.75. So how can I talk about the value of all the dimes? Well, each dime is 10 cents and there's D of them. So 10 times D, 10D, that gives me the value of all the dimes. And then I can do the same thing with quarters, except that each of those is worth 25 cents. So I can write 25Q, and then I need to add these things together. And again, if I add up these two values, it should add up to $3.75. Here I have to be a little bit careful though. I didn't want to use decimals, so I wrote 10 and 25 instead of 0.10 and 0.25. But I've got to be consistent and write my dollar amount in terms of cents as well. So I'm going to write 375 rather than 3.75. And at this point, all you have to do is solve this using either substitution or elimination. And there's pros and cons to each on this. I'm going to let you pause the video again, pick an approach, and solve it. And then you can see my solution. Alright, so I could have gone either way on this one. Some problems, it's easier to use substitution. Some, it's easier to use elimination. On this one, substitution would have been pretty easy. You could isolate either D or Q pretty quickly in this first equation by subtracting the other variable, but I chose to use elimination instead. So in order to do that, I needed to figure out whether I wanted to get rid of D or Q first. And if I just add the equations together the way they are, nothing's going to cancel out. So I wanted to get rid of D. So what I ended up doing then is I multiplied this first equation by negative 10. That gives me a negative 10D, which will now cancel out with the 10D from my second equation. And then everything else gets multiplied by negative 10. So we have negative 10Q equals negative 240. And at this point, I just add these together. So that cancels out those D's. 25Q and negative 10Q gives me 15Q. And then 375 minus 240, that's going to be 135. And then dividing both sides by 15, I'm going to use the calculator on this. So that ends up giving me 9. And now when you write your answer, you should include units in the answer, because this is a real-life problem. So that's going to be 9 quarters. If I just write 9, I don't necessarily know what that means. Now we're not done. We have to solve for the number of dimes as well. So just like any other systems problem, we'll take the value of Q, plug it in an equation, and use that to find the value of D. Probably the easiest equation is this one over here talking about the number of coins. So I'm going to plug 9 into this Q. So that's D plus 9 equals 24. And then subtracting 9 from both sides, I end up with 15 for D. and that's 15 dimes. For our next example, check out this sweet situation. The number of calories in a pie is 20 less than 3 times the number of calories in a scoop of ice cream. Okay. And the pie and the ice cream together have 500 calories. We want to know how many calories are in each of these. All right, so pause the video, define some variables, and set up 2 equations that model this situation. Now, we're trying to solve for the number of calories in a pie and the number of calories in a scoop of ice cream. So I'm going to let P represent my pie calories, and then S is going to be calories in 1 scoop of ice cream. And for my 2 equations, well, I've got 2 pieces of information on this one. They told us the number of calories in a pie, which is P, that means equals, 20 less than 3 times the number of calories in a scoop of ice cream. Well, 3 times the calories in the scoop of ice cream is 3 times S, 3 times the calories in 1 scoop. And we wanted 20 less than that, so that would be minus 20. So this gives us a way of talking about P. But again, this is not enough by itself to know how many calories are in each thing. We also have to use this information about them adding up to 500 calories. So I can say the number of calories in pie, P, plus the number of calories in a scoop of ice cream, S, equals 500. And now I have a system that I can solve. Pause the video and go ahead and solve this using, again, whatever method you feel works best. Now, in this situation, since I already have a variable isolated, namely P, I think substitution is going to be a little bit faster. I mean, you could use elimination on this if you move the S over to the left side and multiply at least one of these by -1, but why make things take longer than they need to? So I'm going to substitute 3S minus 20 for the P over here. So this is going to now just be 3S minus 20 plus S equals 500. And then combining like terms, I've got 4S minus 20 on the left side. Adding 20 gives me 520. And then dividing by 4, let me go to the calculator. So 520 divided by 4 gives me 130. So that's 130 what? Well, this is calories. So this is 130 calories in 1 scoop of ice cream, which actually seems pretty close to reality if you count calories. Now we have to figure out calories in a pie slice there. So we're going to plug 130 in for S, and probably this S is a good place to do it because we've already got P by itself. So we've got P equals 3 times 130 minus 20. So this is 390 minus 20, which means there are 370 calories in a slice of pie. So between the 2 of these, probably if you had to pick one, the ice cream is a little bit healthier, if you could call something like that healthy. For this last problem, we're going to the Spring Carnival, where the price is $50 for a group of 9 children and 2 adults, and $61 for a group of 10 kids and 3 adults. And how do we know this? I don't know. Maybe you just kind of hung out and saw how much people got charged as they went in. And maybe there's no signs posted, so you have to solve this math problem to figure out the admission price for each child and each adult. So let's go ahead and do that. Pause the video, define your variables, and set up 2 equations for this situation. Now, the things we're trying to solve for here, the admission price for a child and an adult, I'm going to let the child admission price be represented by C, because I'm not very creative with my variables. The less creative, the better. And then A is going to be my adult price. And my 2 equations, well, they told me it was $50 for 9 children and 2 adults. So if I take the price of 9 kids, which is 9 times the price of 1 child, so 9 times C, and I add to that the price of 2 adults, so 2 times A, 2 times the adult price, that should add up to 50 for that first group. And I can actually set up a second equation using the same kind of reasoning for this other group that paid $61. So we can write 10C, 10 times the price of a child admission, and then plus 3 times A, 3 times the adult price, because there was 3 adults there, and that added up, that equaled 61. All right, so hopefully you got these equations. Pause the video and solve these however you think best. All right, so hopefully you decided to use elimination on this one. Substitution is always possible where you can use elimination. However, on this one, substitution is always going to require some kind of fraction, which might make things a little bit tougher for you. So with elimination, we have to choose between getting rid of C or A first. And because A has nicer looking coefficients, 2 and 3 are smaller numbers than 9 and 10, I'm just going to get rid of A. So to do that, I'm going to multiply one of these by a number to give me a 6A and one of these by a number to give me a negative 6A. So I'm going to take this equation right here. I'll multiply this equation by 2. So that's 20C plus, and this is the important part here, 6A equals 122. And now I have to multiply this other equation by something that gives me negative 6A. So I'm going to multiply it by negative 3, giving me negative 27C minus 6A equals negative 150. And just like we always do with elimination, we can now add those together. That cancels out my 6A's, and we have 20 minus negative 27, or 20 minus 27 is negative 7C. And let's see, 122 minus 150, that's negative 28. Dividing by negative 7, we get C equals 4, which in real life means that the price of a child entering this carnival is $4. All right, seems pretty reasonable. Let's plug that back into one of these equations. I think this one will work out. So we have 9 times 4 plus 2A equals 50. So that's 36 plus 2A. Subtract 36, we have 14 on the other side. And then divide by 2 to get the price of one adult, because this is saying here that 2 adults is $14. We subtracted the price of all those children. So this is going to be an adult ticket price of $7. And with that, this mathematical ride is over. Till next time, Mr. Sutton signing off.